All right, everybody. I am going to make a video, and I'm afraid it might be a little long, but that's okay. Watch what you want to, skip around if you want to. This is totally an optional video, and it is to help you review for your final exam. So, my plan is to go back over a few problems from each exam's worth of materials. I'm not going to cover every single exam, but I'm looking at some old exam questions. I'm looking at some old final exam questions, and I just want to kind of give you an idea of the types of things that are coming your way. And maybe by highlighting some problems, you'll see what I think were more important things and therefore what might be test questions on your final exam. So hopefully this helps you prepare better for the final exam. Hopefully you have been looking at all of your exams and working through stuff, and hopefully this just kind of you're able to work along with me. And no problem if you are still completely and totally dependent on me to show you exactly how to do this, then maybe you haven't been studying the old exams like you should be. The idea is to work through the problems and then check on the key or then check with the video, right? So hopefully you can do that. Find the domain. I've got two different problems I want you to work on. So one is where the function is 3x minus 7 over 2x plus 5. And I want you to think about domain problems. So there are two basic domain problems that you have to worry about. And because this is a rational function and we have a little polynomial there on the bottom, hopefully in my head I hear you saying, don't divide by 0. Yes, so I hope we've done this like a gazillion times this semester. So hopefully that is all up in your head, right? Don't divide by 0. Okay. So the trick here though is how do I deal with this particular problem and make it so that it looks like don't divide by 0. Well, the idea we had was take the denominator and say 2x plus 5 cannot be 0, right? That's how we say out loud, don't be 0. Okay. Literally, 2x plus 5 can't be 0. 2x can't equal, I'm going to subtract 5 from both sides. 2x can equal -5, and then get the x by itself, and you should have x cannot be -5 halves. And seriously, I hope you can work through that just as quickly as I just worked through it. Just as a heads up, remember we want to do interval notation. So what's going on here is that I've got all real numbers except x can't equal -5 halves. That's my domain. We said find the domain, right? So to get that interval notation, remember we always start at the very, very far left, which is -infinity, and we're going to come up until we run into one of our bad spots. In this case, there's only one. -5 halves, and we say we can never equal -infinity, so it's a parentheses, and we don't want to be -5 halves because that would be a 0 on bottom. That's a bad spot, so it can't be -5 halves, so we put a parenthesis. Okay, so it's like the graph's going along, beep, 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 beep. Remember, that's a vertical asymptote going to come in there, so not -5 halves. But we do want to pick back up on our graph and go on out to positive infinity. So there's your interval notation, okay? And remember, we want interval notation. So hopefully everybody knows how to do that, okay? So that's one thing we have to worry about whenever we're looking at domain. And the other thing we have to worry about looks something like this. What if f of x was... And remember, they don't always have to be functions of x, but a lot of times we just fall back on x's because that's where we are. I'm going to scoot. F of x is the square root of 5x minus 10. Okay, this is a different situation. We're not dividing here, so I don't need the don't divide by 0 rule. What I need here is the don't take a square root of a something number rule, right? It's actually even roots, second, fourth, so on, but we usually say square root. So what can't this be? No square root of a negative number, right? That's my second issue in the domain. If I see a square root, I go, oh, can't have a negative number there. Oop, don't put a negative number in there. If this was square root of negative 25, we'd be like, oh, it throws me into imaginary numbers. I got 5i, right? That's a problem. So don't do that. Okay, that's what we're telling ourselves. So again, how do I make it so that I know the value that gives this guy a negative number? Well, here we say let the stuff inside 5x minus 10 be greater than or equal to 0. Okay. Square root of 0 is okay. So the equal sign is okay. But what does that square root do? It makes it, I'm sorry, that greater than sign. It makes it be positive, right? So add over the 10. 5x is greater than or equal to a positive 10. Divide by the 5. X is greater than or equal to 10 over 5 is 2, right? That's what we're looking at here. All right, cool. So, and that's the difference. Whenever it's a divide by 0 case, we are going to have one point that we can't do. You just can't have a negative 5 halves here. But here, what we're saying is, oh, it's got to be greater than or equal to 2, okay? If it's equal to 2, let's check it. 5 times 2 is 10 minus 10. That is the 0. That's okay. But what if it was less than 2? Okay, let's stick in 0. It's my favorite number, less than 2. 5 times 0 is 0. Minus 10 is negative 10. If I put in a 0 here, I'm taking the square root of a negative 10, and that throws me into imaginary numbers. So that's what we're trying to avoid. That's why here we have a whole bunch of values. Anything that's less than 2, we're going to be in trouble with, right? So again, how do I do this in notation, interval notation? Well, here I went from negative infinity up to this guy and then just had one little hole that I jumped, right? One little gap and went on up. But here we're saying it's a whole a procession of numbers, so to speak. So x has to be greater than or equal to 2. So that means I'm going to start at 2. I'm not going to be down here at negative infinity. I'm not even going to do negative 5 halves because that is going to make me have problems. So I need everything greater than 2. So from 2 to infinity, and let's talk about this. Again, infinity, always a parenthesis. Nothing to talk about there. But what does this equal sign tell me? Equal sign says that's like we put the equal sign here, hard bracket, right? So it includes the 2 and does everything above, which means if you put in, say, a 10 here, 5 times 10 is 50, minus 10, that's 40. Square root of 40, it's not a pretty number, but hey, it is indeed a positive number, so we're okay. All right. Those two things for domain. And I'm going to just pretty much promise you're going to see one of each on your final exam. So go ahead and make sure that you can do those. All right. Next important question here that I see on this particular old exam that I'm looking at says on this test that I'm looking at is a 4. That's not necessarily your test. Given the 2 points, write the equation of the line. Okay. And the points are -8, 7, and 1, -6. Okay. So here's the deal. You have to know what to do with this. Okay. I just have 2 points, and somewhere there's going to be a formula sheet. And on that formula sheet, it's going to say stuff like quadratic formula and things like that. It's not going to tell you what the formulas are, but somewhere you're going to see this formula y2 minus y1 over x2 minus x1. And what is that? That's your slope formula, right? So before I can write the equation of a line, I have to know the slope of the line. Remember, a line is going to be like a straight thing here, and the slope is a constant number here. And the other thing that, and it's just rearranging this, that you should be able to see is y minus y1 equals m times x minus x1, where in this case, the x and the y are going to stay generic. We're not going to substitute for them, and we're only going to substitute in for the x1 and the y1. Okay, so those two formulas are going to be somewhere on the formula sheet, and hopefully you see them. This is the point slope form of a line. You see it, you recognize it, you grab it, you say, hey, let me do the slope formula. So I'm going to do that first, m equals. And then once you know your slope, you're going to grab this formula and you're going to plug it in and find the equation of a line. Equation of a line, this one's almost always the one we use. Okay, so I don't care which one. I'm going to just call this x1 and y1, and I'm going to call this x2 and y2. You can pick at the other points. Just make sure that your negative signs are in the right order. So the formula says y2, which I'm saying is -6, minus, because there's a minus sign there, y1, which I'm saying is 7, over, and then it says x2, which I'm saying is a 1, minus x1, minus is from the formula, right? And then x1 is a -8. So I'm going to plug in -8 there, right? -6 minus 7, -13. 1 minus a -8 becomes 1 plus an 8. That's a 9. -13 ninths. It's not pretty, but that's my slope, dang it. Okay, so we get our slope there, and then we say, okay, we've got a slope. We've got 2 points. You can pick whichever one you want, and we have the slope point slope form of the line. So let's stick it in there and see. So the formula is y minus, I need a y1. And again, I'm just going to pick this one. It doesn't matter. You can pick either point. So y minus, I'm going to say 7 equals m. Okay, what was my m? We just found it. M is -13 ninths times x minus, and what's my x1? I picked this guy for my the 7 for my y1, which means -8 is my x1. So it's a minus from the formula and a -8 because that's in the point. So again, be super careful with our negative signs. We're going to see the negative and the negative here in a second is indeed a positive. So x plus 8, right? And then from here on out, it's just get the y by itself. So we need to distribute this guy through. Y minus 7 equals -13 ninths times x. I'm going to stick that 8 over 1, and I'm just going to plug this on my calculator. It's too late in the semester, and I'm too tired to be doing any of that stuff in my head. So 13 times 8 is 104, and it's a -13 times a positive 8. So -104, and on the bottom, I've got 9 times 1. That's a 9. Remember, top times top, bottom times bottom whenever I'm doing these fractions. All right, and we're almost done. We just need to get the y completely by itself. I'm going to add 7, and again, it's 7 over 1. I'm going to multiply the top and the bottom there by 9 because I need a 9 common denominator, right? So what happens is this. The 7's go away. I get y equals -13 ninths x. I'm going to rewrite this just so we can see it. Minus 104 over 9, and then plus 7 times 9 is 63. 1 times 9 is 9. I need to add those two numbers together. Y equals, I've got -104. I'm not doing any of this in my head. Plus a 63 is a -41. Minus 41 over the 9 because you got the common denominator so that you can combine the tops and keep the denominator the same. There we go. There is my equation of the line. Okay. And just be aware that on that, you're not finished until you simplify this. So you can't just say like plus 7 out here and leave that, right? You've got to combine those two like terms right there. So make sure you're doing all of that. Okay, so I'm pretty sure there'll be one similar to that. I feel like there's going to be one where you have to talk to me about the asymptotes, because we talked a lot about rational functions. So again, on this test that I'm looking at, it says give the vertical isotopes and the horizontal isotopes, if any. Okay. So h of x equals 7x squared minus 3x plus 22 all over 2 times x minus 4, x plus 2. Okay. So let's hit vertical isotopes first because we already did domain. So this is a nice thing to see. Vertical isotopes are bad spots in the domain. Okay. And remember, we just did this. So how do I find a bad spot? This is division. I want this guy, 2 times x minus 4 times x plus 2. That guy cannot equal 0. Okay. And I think the vertical isotopes are probably for most people the easiest. So each of these factors cannot be 0, right? So either 2 isn't 0, or x minus 4 isn't 0, or x plus 2 isn't 0. Well, what about 2 isn't 0? That doesn't even make sense. So that goes away. But this one, I could add 4 to both sides. X can't be positive 4. Oh, that makes sense. That's a good vertical isotope. And on this one, what? Subtract 2 from both sides. X can't be negative 2. And again, I really hope at this point you're running through that kind of thing that quickly. You look at that and you say, oop, I need to find the bad spots in the domain. Let me take that denominator, say it can't be equal to 0, find my values. Okay, here we go. X can't be 4, X can't be negative 2. Those are my vertical isotopes. Vertical isotope at X equals 4, X equals negative 2. And yes, you need to write these as equations because they are vertical lines. Okay. All right, so that's the vertical isotopes. The second part is the horizontal isotopes. So let me run through. There are 3 rules for horizontal, if you'll remember. And then we'll come back and look at this particular problem. So horizontal isotopes look like this. Say I've got 5x cubed over 2. Well, let me steal the one we got right here. Well, 7x cubed over 2x. Let's do that. Okay. Remember, the idea behind horizontal isotopes is the top or the bottom pulling more. This is a tug of war that's happening between the top and the bottom. Remember, a horizontal line is a line that looks like that. It's y equals some number, and we're not supposed to cross it except for occasionally in the middle, right? So in this tug of war, we don't really care about the coefficients. We care about the exponents on those variables. So if the exponent on the top is a 3 and the exponent on the bottom is a 1 on that variable, I don't write it, but that's there, then which is stronger? Okay, in this tug of war. It's bigger on top, right? Okay, that's no horizontal isotope. Okay, that's what's going on there. Okay. What if it was bigger on bottom? So let me just switch these. 7x over 2x to the third. Okay. If it's bigger on the bottom and I look at these guys, which one is stronger? The bottom one's stronger, right? Okay. So bigger on bottom, that means that as I get really big, remember this is end behavior that we're talking about here, not in the middle when I'm talking about horizontal isotopes. But if I put in a 10, if I put in 100, if I put in 1,000, If I get up to 1,000 here, but it's 1,000 cubed there, then the bottom's going to win this tug of war, right? Okay. And what happens when I take a Hershey bar and I divide it into, say, 1,000,000 pieces? How big are those pieces? Really, really, really tiny. Probably not even worth talking about. There's a horizontal asymptote at y equals 0. Okay. That's the second situation. And then the third situation is, let me, again, still these same numbers, 7x squared over 2x squared. Okay. Now when I look at those variables, what about this tug of war? They're the same, right? They're the same. And so now I say, oh, they're equally as strong. In fact, I could just reduce those out, right? And what would I be left with? The numbers out in front. Now the numbers out in front make a difference. So there's a horizontal asymptote at y equals 7 over 2. Okay, that's what's going on there. So that's how I explain this particular situation with horizontal asymptotes. If you were looking stuff up online, you might have seen Bobo Botten eats DC, which is a crazy made up mnemonic so that people can maybe remember a little bit about these. So let's remind us what that means. If it's bigger on the bottom, meaning the exponent on the bottom on the variable is bigger, then you get y equals 0. That's a 0 there. If it's bigger on the top, there's none. That's what this n means. And then here is if the exponents are the same. I never can hardly remember this one. If the exponent are the same, that's eats, right? Then we divide the coefficients. Okay, so it looks like there's an exponent at, and we would say A1 over A2, the first leading coefficient over the second leading coefficient. So there's your little 3 rules, both explained for us and in that little mnemonic. If you can remember the mnemonic, great. If you have a different method for remembering them, great. It doesn't really matter. What matters is that you can apply it. Okay, so let's look right here and be really careful. Okay, what's the exponent on the top? The biggest exponent, right? We don't care about that guy and that guy. The biggest exponent on the top is a 2. Okay. And be really careful here because if you just come in here, you're going to say the biggest exponent on the bottom is a 1. But that is not true because these things are multiplied. And what happens when I do x times x, when I distribute this guy through? X times x is x squared, right? So the exponent on the bottom is a 2. Exponents are the same. What does that mean? Divide the coefficients, right? So for this example, there's a I'm going to put it right here. Horizontal asymptote at y equals 7/2. Okay. And now you know why 7/2. Now you know why I use those two numbers because it's exactly this situation that we're dealing with, right? Okay. So make sure you know all that good stuff. You're probably going to have one word problem somewhere on this test. What else? There is some logarithm stuff in here. On the test I'm looking at, says solve without your calculator. Okay, that literally means I don't want you using your calculator. I want you to use rules that you know. Okay. I want you to use your brain. I don't want you to use any crazy log buttons or anything like that. So hopefully when you look at this, you see I've got some base and some exponent is equal to some answer. And hopefully you look at this and you go, hey, 16, isn't that not only a multiple 2, but a power of 2? And the answer is yes, it is. 2 to the x plus 1 is equal to 2 to the, let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16. So it's 2 to the 4th. Okay. And why did I do that? Because we have a rule in our back of our heads that says, hey, if I can get both sides of this equation to have the same base, then if the bases are equal, then the exponents are equal, right? If the bases are equal, the exponents must be equal. Okay, and they must be. So I say, hey, this 2 is equal to this 2. Therefore, I can set the two exponents together. X plus 1 equals 4. And then, of course, we want to solve for that guy. X equals 3, right? All right. So, and you should be able to what? Real quickly say, hey, X is 3. 2 to the 3 plus 1 is 4. That's going to be a 4 up there, right? 3 plus 1 is 4. Yeah, that is 16. Hey, it worked. Yay. All right, great. Let's see. I do want you to do a couple of little logarithm type things. That was just an exponent thing. Notice I didn't invoke any kind of logarithms, but I do want you to use some exponent or logarithm type things. So I'm going to give you one or two of those. Log base 3 of 1 over 27 equals x. What do you think? Remember, log base answer equals exponent. A logarithm is a really fancy way to write an exponent. Hopefully we remember that, right? Okay, so log base answer equals exponent. Why do I care about that? Because the exponential form looks like base to the exponent equals answer. So I should be able to rearrange this, right? Let's see, base to the exponent would be what? 3 to the x equals the answer, which is 1 over 27, right? This is my answer right here because it's right here. Log base answer equals exponent. Okay, so now I just really need to say, hey, again, this is a 3. I think this is some power of 3. Now be careful because it's on the bottom. That automatically means it's a negative exponent, right? Negative exponent. But what is it? 3 times 3 is 9, times 3 is 27. So this is 3 to the x equals 3 to the negative 3, right? 3 times 3 is 9, times 3 is 27. So 3 to the negative 3. And again, we're invoking that property that we used just a minute ago in number 9, where we said, if I can get those bases to look like they're the same thing, then what? The bases are the same, the exponents are the same. X equals negative 3. But there it is. All right, so that's not too bad. We can do those kinds of things. Just to jog your memory, recall that if you see something that's an ln, ln of e to the third equals x, then what base is that? This is the same whenever I write ln, that's natural logarithm, is the same as writing log base e of e to the third equals x. And now can I do log base answer equals exponent? Yes, we can. So what's the base? E raised to what's the exponent? X equals all of that answer, e to the third. Hey, that's pretty good. E to the x equals e to the third. They have the same base. So what? The exponents are the same. That's what I hear. That's exactly what I'm hearing. All right, so there we go. I'm not going to do every single example of logs. You will have logs on this test. Let me do one or two where we have to use some solve type stuff. use some of our properties to solve some stuff. So I'm skipping just a tiny bit here. I'm going to 12b. It says log base 3 of x squared plus 1 equals 2. Okay. And this is the same thing we did just a second ago. It's just that this is a little more complicated, right? It's still log base answer equals exponent. It's just that the answer is bigger. So let's see if we can rearrange this. 3 is the base. 2 is the exponent. Base to the exponent equals all of my answer, right? X squared plus 1. It's a little more complicated than a second ago, but we can deal with it. All right, so everybody see that. Base to the exponent equals the answer. Log base answer equals exponent. All right, so we can deal with this. 9 equals x squared plus 1. Okay. You can solve this like try to factor or try quadratic. I'm going to just go ahead because I see there's no bx term, right? It's just x squared and some number. So 9 minus 1 is 8. I'm just going to get the x squared by itself. Okay, so move the 1 over, get the x squared by itself. I flipped sides. Okay, and then I can use the square root property, right? X squared, I want that just to be an x. Whenever I do that, I do it to the right-hand side. Don't forget your plus or minus. Oh, pluses or minuses. So I'm going to come over here. X equals, because those go away, plus or minus the square root of 8. And I say leave it alone. Oh, let's double check real quickly. Leave it alone as far as your value goes. You don't need a decimal or anything like that. Just leave square root of 8. But I do need to check because I'm dealing with logarithms here. And what do we know? If I try to take the logarithm of a negative number, I'm not going to do this problem, but let's just say we have log of, say, -3. Okay. What's going to happen? That guy's going to tell me error. And it says non-real answers. Remember, whenever before I start shifting stuff, the basic graph of a logarithm is that there's a vertical asymptote right there, and it goes through this point, 1, 0, and the logarithm looks like this, right? There's some other stuff, but that's the basic graph of it. So I cannot put -1, -2, -3, whatever into a logarithm unless there's something else going on. And here, if I put in negative square root of 8, what happens right here? Negative square root of 8, a negative squared, negative times a negative is a positive, right? So in this case, I can use both of those. But if it wasn't squared, if it was just like -8 plus 1, -7, log of 7, -7, nope, can't do it. Okay, so you do really, really need to check your answers here whenever you're dealing with the logarithms and negative numbers. So watch it. If it's not just an x inside of the logarithm, you need to check. Be careful. All right. Keeping on going with these logs. I think I'm just going to do one more logarithm and then we'll move on from that. But they will be on your test. Number 14 on this test that I'm looking at says log of x plus 3 plus log of x equals 2. And it says use your knowledge of log properties to solve. This other one said solve too. I didn't write it down. Sorry. Okay, use your knowledge of log properties to solve. And when I see this, I see two separate logarithms that are being added. And in my head, I think, remember that exponent rule. If I had x squared times x to the third, I would add those exponents, x to the fifth, right? So that old exponent rule is whenever I've got the same base and I was multiplying something, I could add the exponents, right? Remember, logarithms are just fancy exponents. Okay. So the other one, just in case you were worried about it, is x to the fifth over x squared. If I was dividing, what happens there? If you had some division going on inside of a logarithm, then it would be subtraction, right? So this one is addition, so we're going to use this rule right here. Okay, the addition must have been some multiplication going on inside of that logarithm that got me that addition, but because I'm going to cram these back together. But don't forget there's other rules out there. And while I'm at it, let me just get the third rule so everybody knows. X squared to the fifth power. What about that? A power raised to a power is we multiply, right? Okay. So sometimes you'll see something like log of x squared, and they'll bring this power out in the front and multiply to log of x. Because it was a power to a power, we multiply. Okay, but here we're going to use this addition came from multiplication rule. So I'm going to cram it into one logarithm. The logarithm of this addition between these two logs must have been x plus 3 times x multiplication equals 2. Okay, why do we bother doing that? Because I can't invoke that conversion thing to make this into exponential where I go log base answer equals exponent. I can't use that until I just have one logarithm. Right there, I had two logarithms. That's not log base answer equals exponent. So I can't use that conversion. But now I can. And by the way, what's the base here? It's not written, so it must be a 10. Okay. So log base x answer equals exponent. There's my base. There's my exponent. 10 to the second equals whatever this answer is, x times x plus 3. It's just getting a little bit more complicated there. You can deal with it. Okay, 10 squared is 100. I'm going to distribute that x in. Okay, x times x is x squared plus 3x. Okay. And now what I've got is actually not too bad, right? I'm going to rearrange this. 0 equals x squared plus 3x plus 100. Okay. They want me to solve. I've got a quadratic here, and I'm looking at it going, that guy's not going to factor, right? So, hopefully everybody's a pro with quadratic formula by now. Hopefully you're pros with factoring by now. It's the end of the semester, and like week 1, I said, do your factoring review, right? So this guy's not going to factor, so we're going to have to quadratic formula edit. X equals plus or minus b. I'm sorry. Yeah. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That is a formula. It will be somewhere on your formula sheet. As a hint, the left-hand side is algebra stuff, guys. The right-hand side is calculus stuff on my formula sheet. So test 1 material is on the left. Test 2 material is on the right. Unless you need a quadratic formula from test 1, then on the test 2 stuff, then you might have to do it. Okay, what here? What's my A? There's really a 1 out there, right? A equals 1, B equals, what's my B? 3, and C equals, what's my C? 100. So, and again, hopefully you can do it just that fast. X equals negative B, negative 3 plus or minus square root of. The B squared is a 3 squared minus 4 times the A is a 1. The C is a 100. I know I'm blasting through this, but hopefully you can blast through it just that fast, okay? All over 2 times, what's my A? A 1, okay? So you're going to substitute that sucker in, and you're going to be like, boom, I can work this out, okay? So x equals negative 3 plus or minus. Hopefully you can simplify this stuff. 3 squared is 9 minus 4 times 1 times 100 is 400. That's a negative 400 all over 2. Okay, what do we got there? Oh, wow. That's, oops, did I lose a negative sign? Hang on. I'm sorry. I wasn't expecting a negative there, and I shouldn't have one. It's because nobody's in my classroom with me when I subtracted this 100 off. It needs to be negative, negative 100. Yep, we all do the negative mistakes. Watch out for it. So now I'm getting a negative. How did I know I had a mistake somewhere? A negative times a positive was a negative, and I know I want this to be a real answer. And so hopefully it's a positive in there, which will give me a positive 409, right? Not an imaginary number. I'm not looking for imaginary here. All right, so I need to do some estimating. I need to know what 409, the square root of that guy is. Square root of 409 is about, let's call it about 20. Negative 3 plus or minus 20. Excuse me. Negative 3 plus or minus 20 over 2. I'm so sorry. I had a tickle in my throat. All right. So remember that we're going to split this guy up so that we can work with it. This is two answers, right? This is x equals negative 3 plus 20 over 2. And again, we're estimating this is 20. It's a little bit bigger than 20, but it'll be okay. X equals negative 3 minus 20 over 2, right? Okay, so in this case, I've got negative 3 plus 20, that's 17 over 2. And I happen to know if this was 16, that would be 8. So this is 8.5 or 8.5. If you want to get it on a decimal, that's fine. Any of those works. Or negative 3 minus 20, x equals negative 23 over 2. Again, if this is 22, it would be a negative 11 and a 1/2, right? Or negative 11.5. Oops, sorry. Okay, so that's where I'm sitting at. I've got those two answers, and again, you better check them, right? Let's make sure they both work. So here I have about 8.5. 8.5 plus 3, is that okay? Yeah, that would be log of 11. It's not pretty, but it's okay. Excuse me, log of 8.5. Am I okay there? Yeah, that one's okay. It's a positive. I'll get some weird decimal or something. It's all right. Okay. But this one, I hope this one's sending up warning bells for you. Let's look. We're doing log of negative 11. Negative 11 plus 3 is a negative 8. Oops, sorry. Not there. Negative 11 plus 3 is negative 8. And what do we know about log of a negative number? Nope, can't do it, right? Also here, log of negative 11, can't do it here either. So it's a double whammy. We can't do it. So that one doesn't work. Remember, we call that an extraneous or extra root, and it's just not going to work, and we just dump it. So here we have one answer, and it's about, do your little curly brackets. It's about 17.5 or 8. I'm sorry, 17 halves or 8.5. All right, there we go. Let's keep going. See what we got here. Okay, I think that's about it for exam 1. Again, there's going to be some word problem-y type stuff. There's lots more for you to look at, but that should give you a really good review of what kind of stuff was in exam 1. I know for some of us, it's been a long time since we looked at exam 1, so some of us are like, ooh, let's remember. It's been a while. Okay. So next is exam number 2 material. If you remember, that's where we started moving into derivatives, and increasing and decreasing and concave up and concave down, all those things. So let's remember some basic rules. I'm looking at an old test, and on this one, it's number 5. And all of these just say find the derivative. Okay. And on this problem, I've got f of x equals 2508. What do you think about that? The derivative of a constant is 0, right? So f prime of x, remember that's how we say derivative, is 0. Any constant. Derivative of any constant is 0. All right, let's hit number 6 real quickly. G of t equals 25t to the third is my example. And hopefully you know that g prime of t is... Okay, what's the rule? This is a what? This is a power rule, right? So what do? We take the exponent, we multiply it out in front. 3 times 25 is 75. Put your variable down, and what happens to the exponent? Subtract 1. Yep, take 1 away. That's a basic power rule, and on this test I must have been feeling nice because that's a pretty straightforward power rule for you to get points for. So hopefully everybody's good with that. Number 7 on this test says f of x equals x to the 2/3. Okay. This is also a power rule, but some people are bugged by this because why? Because this is a fraction. Okay. It works the same way though, right? Multiply the fraction out in front. This happens to be a 1. So that's 2/3 x to the... subtract 1 from the exponent, right? 2/3 minus 1 is negative 1/3. Okay, so be careful with that. Sometimes we go negative whenever we subtract a 1. It happens. It's okay. All right. Real quickly, number 8. F of x equals 8x to the negative 4. I just want to show this. Again, these are still power rules. This was a power rule, and this one is a pretty power rule, right? But I want to show it why, because that exponent is negative. Okay. So sure, we can do this. F prime of x equals... multiply the negative 4 out in front times the 8. Negative 4 times 8 is negative 32. X to the... and what happens whenever I subtract 1 from that exponent? Negative 4 minus 1 is a negative 5. Remember, I'm going more negative, so it becomes a negative 5. That is not a negative 3. I did not make a mistake, so watch out for your exponents and your signed numbers and stuff like that. We can all do it. Just be careful. All right, so those are all power rules. Okay. And then I decided to be a little more mean. So here we go. Find the derivative when f of x equals 5 plus 6x squared times 3 minus 4x to the third. All right. This is not a pretty power rule, right? What is this? This is a polynomial here and a polynomial here. And what's going on with them? They're being multiplied. So what rule was that? Product rule. Okay, so remembering that if we have some big function where we've got f of x times g of x, two functions that are being multiplied together, and I want to take the derivative, f prime of x equals, what was it? The first guy times the derivative of the second plus what? The second guy times the derivative of the first. Okay, so in this particular product rule, it doesn't really matter which order I do it because the plus order and addition doesn't matter, but it does matter in each of these little parts. I've got f of x and g of x. So the regular function and then the derivative of that other function, right? And then I've got g of x and f prime of x. So again, I'm representing both functions. It's just that one is the regular guy and one is the derivative guy. And again, that plus order doesn't matter whenever I add. So let's see. F prime of x equals the first guy, just the way he is, just rewrite him. Write that piece just exactly like it is. If you need to, cover up that second guy. Okay. Times the derivative of the second guy. Be careful about this. What's the derivative of 3? 0. What's the derivative of this guy? This is where I saw lots of mistakes on this test. 3 times negative 4 is negative 12, right? A lot of people lost their negative. Negative 12. X to the minus 1 is x squared, right? Plus, because that's what the formula says, plus. The second guy, rewrite him exactly like he is, 3 minus 4x to the third, times the derivative of the first guy. What happens to the 5? Derivative of a constant is 0. 2 times 6 is 12. When I subtract 1 from that exponent, I just get x, right? Okay, so there we go. That's just applying the product rule, right? We're not finished because we need to make this guy look prettier. Don't forget to clean these things up. It's been a while since we had to do cleanup work, okay? So f prime of x equals, I'm going to distribute, okay? Negative 12x squared times 5. Okay, plus a minus is negative 12x squared times 6x squared. I'm going to have to do some stuff with those exponents. Plus 12x times 3 is 36x. Negative 4 times positive 12 is negative 48. X to the third times x is x to the fourth. So you're going to have to really watch this because doing things like this, I'm going to end up with totally different exponents than what I started with. So this is what? Negative 60x squared. This is also negative. Negative 6 times 12 is 72. But what's going on with these exponents? X squared times x squared is x to the fourth, right? Okay. Plus a 36x minus 48x to the fourth. Okay, so let me scoot this. Come back to you in a second. All right, where are my like terms here? Negative 72x to the fourth and negative 48x to the fourth. Let me just double check real quickly that I don't have a negative sign off. Negative 48, negative 72. Yep. Okay. 72 and 48, they're both negative, so I'm going to add them together and give them a negative sign. Negative 120, right? So f prime of x is negative 120 x to the fourth. I got those two. Minus 60x squared plus the 36x, right? There it is. And could you factor some x stuff out of here, even an even number? Sure, you could, but I say leave it alone. You do need to clean up your math whenever it looked like that. For sure, you should be able to here it was. For sure, you should be able to multiply 12x times 3 minus 4x to the third, right? So arithmetic type things, early basic algebra type things like that, yeah, I expect you to be able to do them. So clean those up, but there's no sense in going overboard with working extra stuff, in my opinion. All right, number 10 on this test says find the derivative, and we have this guy. G of x equals 6 plus 4x to the third over 5 minus 2x squared. All right, what do we think about that guy? Is that a product rule? No. Is that a power rule? No. What is it? It's a quotient rule. Okay. And again, I hope you remember your quotient rule. Basically, it looks like this. I've got a function divided by a function or a polynomial divided by a polynomial, then I know they are being divided. That's a quotient, right? And whenever I have that, I have f prime of x is, okay, and this matters. Low d high, the low guy, d high times the derivative of the top, the order absolutely matters here. Low d high minus, that's why the order matters here because we're subtracting, high d low, the top guy, times the derivative of the bottom all over the bottom guy squared. Remember that formula? Again, it'll be on the formula sheet and it'll be on the right-hand side because that's where all the derivative stuff is, right? Okay, here we go. Let's do it. G prime of x equals the bottom guy, write him just the way he is, 5 minus 2x squared, times the derivative of the top guy. Well, derivative of 6 is 0. What's the derivative of this? 12x what? Squared, right? Okay. Minus low d high minus high d low. Here's my top guy. Write him just the way he is. Put him in parentheses. Put all of these tops and bottoms and firsts and seconds. Put them all in parentheses. I do it all the time. I expect you to do it because what happens if I leave off the parentheses here? I get a minus 6 and I don't bother to distribute into that 4x cubed, and that's a problem, right? Okay. Low D high minus the high guy times the derivative of the bottom. Okay, derivative of 5 is 0. Multiply here, minus 4x. And this is 2 minus 1, or just the first. I'm going to leave it alone. Okay. All over the bottom guy squared. Low, low. 5 minus 2x squared. Squared. Okay. And again, don't bother to multiply that thing out on the bottom. I don't care. Okay. I don't care what the bottom is. We'll leave it alone and it'll be fine. Distribute this guy. Distribute this guy. Don't forget the minus sign out in front. He's going to play a part here. So let's make sure we give him his due diligence. G prime of x equals, distribute this, 12x squared times 5. 12 times 5 is 60x squared. 12 times negative 2 minus 24. X squared times x squared is x to the 4th. Okay, notice that those exponents got really big again. Okay, I'm going to put this minus and I'm going to put parentheses. I'm going to distribute this guy and then I'm going to come back and deal with that minus out in front. Okay, but I see I've got this double distribution thing, so let's do it. Negative 4 times 6 is negative 24. 6 times negative 4x is negative 24x. Ignore this minus for just a minute. And then distribute here. Negative 4 times negative 4 is a negative 16. X cubed times x is x to the 4th. Okay. So I also need to distribute that negative. Don't forget he's out there. All over, and I'm just going to write 5 minus 2x squared squared. I mean, if you really want to multiply that out, do it, but I just feel like it's wasted time. Don't stress yourself out with it. We can deal without it. Okay. We don't need that, so I'm not going to bother. 60x squared minus 24x to the 4th, and this is going to be minus a negative 24 is a plus 24x. And minus a negative 24x, sorry, and minus a negative 16 is plus 16x to the 4th. All over that stuff. Oops. 5 minus 2x squared. I can't even just copy it without making a mistake. So it happens, guys. Minus and positive. Those are x's to the 4ths, right? g prime of x equals negative 24 plus 16. I think that's a negative 8x to the fourth. And then I got a positive 60x squared. And then I got a positive 24x all over 5 minus 2x squared. And again, right here, I know that you could probably like pull out some x squares and stuff like, or x's from the top, things like that. But I just don't see where it's that useful. So I'm going to leave it alone. All right. So that is the quotient rule. And probably, that one's pretty in depth. Probably we messed that one up sometime. So just watch it. Low-D high minus high-D low, low, low. Okay. I'm going to skip here to 12. Number 12 says, find the derivative. F of x equals x squared minus x raised to the 297. Okay. So I gave you 297 or whoever had this test. I gave them 297 because I didn't want you trying to multiply that stuff out. I don't want you multiplying this out, and I certainly don't want you to try to multiply it out when the exponent is 297. So we're just going to use, oh, by the way, this looks like a power rule, but then there's some stuff on the inside of my power rule, right? If it was just x to the 297, it would be a straight up power rule, but it's got some stuff. So what rule is this? Chain rule, right? Okay. And the chain rule says when you've got stuff, it looks like this, f of x equals f of g of x, a function inside of a function. Then we take that derivative by finding the derivative of the outside function times the derivative of the inside function, right? Okay. And here, this is going to keep, this is going to keep the g of x on the inside. I think it's that bugs people. Like, leave that stuff alone, okay? So here we go. F prime of x says, take the derivative of the outside function. So ignore this stuff in here for just a second. On the outside, it just looks like a power rule. So the rule is multiply this out in front, leave the stuff alone, and what? Subtract 1 from that exponent, 296, right? The thing that bugs people is leave the stuff alone. This is the stuff on the inside. It stays there when I'm taking the derivative of the outside function. When I mess with the inside function is after I've taken the outside function. Now I want to take the derivative. So I took this guy, leave the g of x in there. Now I want the derivative of the outside or the inside function. Well, what is that? Well, that's just times, take this 2, multiply them out in front, 2x, 2 minus 1 is 1, minus what's here? This is 1, right? Minus 1, x to the 0, it's just a minus 1, right? Don't forget that last term, though. That's the derivative of the inside stuff. So it's the derivative of the outside function, leave the inside alone, times the derivative of the inside function. And again here, not a lot of cleaning up because I deliberately made this stuff right here something that you are not going to want to multiply that out. Okay, don't bother with it. So leave it alone. We're going to say f prime of x equals. We are going to multiply this and this. Those two are multipliable, right? 297 times 2. Oh, Lord. My brain is shot. 297 times 2 is 594x. So I am distributing the 297 into that second set of parentheses, right? So 594 right here, x minus 1 times 297. Put that in parentheses, please, 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 please. It's not just going to be the 297 times this stuff. All of this is being multiplied. So put it in parentheses. X squared minus x to the what? 296. Okay. And again, I like to make that exponent really big so that you're not tempted to try to multiply that out. Who's going to spend the next 3 days multiplying this out? Not me. Okay, don't do it. Leave it alone. All right, so those are all of our really big derivative rules, right? We've got power rule, we've got the constant rule, we've got the power rule, product rule, quotient rule, and chain rule. That's the big stuff for those rules. And excuse me, hopefully everybody knows how to deal with that. Again, some function stuff, some word problem type stuff. But I want to make sure that everybody can do a first derivative and a second derivative. So that's the last of the stuff. Oh, well, that and taking a derivative by hand. So all of those were on your first exam, and of course they're all going to be here on the final. So first derivative test. Okay, the problem that I've got here says f of x equals 4x to the third minus 27 x squared minus 30x plus 22. It says find the derivative of x. So do that first. Part A. Everybody listening to this video better be able to do this. Okay, f prime of x is what? 12x squared minus 54x minus 30, and the 22 just goes away because it's a 0, right? Okay, so find the derivative. And then part B says use the first derivative test to find any intervals of increase, decrease, or constant slope. That's what we want to know. From where to where is it increasing, decreasing, or constant? And we also want to know if there are any local maxes or mins. Okay, that will come out. Okay, so as a reminder, here's what we're going to do. Steps. Take the derivative. Set it equal to 0. Solve for your variable. Okay, and these 3 steps we do over and over and over again. And then once we've done that, we're going to do a sign chart. Figure out, okay, solve for the variable. That's my critical values, right? CVs. Do my sign chart, and if needed, which it will be, we're going to pick some test points. Okay. Then the last step is interpret, right? Okay, and these steps are actually exactly the same steps whenever it comes to the second derivative test, except for right here, it's going to say take the second derivative. And then it's going to say set it equal to 0, solve for the variable, find your critical values, use a sign chart, test points, interpret. All of that is exactly the same. Okay, so here we are. We have our derivative. Step 1 is done. We're going to set it equal to 0. 0 equals 12x squared minus 54x minus 30. I'm going to, step 3 is solve for x. Before I do this, I know that this thing's going to factor, and you should be fairly confident that yours are going to factor also. I'm looking here and I say, hey, all of those numbers are divisible by 6, right? Maybe something else, but for sure 6. So 2x squared minus 9x minus 5. Okay, I think it was just the 6, but there we go. That's a much nicer, those are much nicer numbers. This is a lot easier for me to factor it, right? So let's see if I can factor this 2x and x. We need factors of -5. One of them is going to be multiplied by 2x. I think it's going to be -5 and plus 1. 2x squared minus 10x plus 1 is a minus 9x. And then 1 times -5 is -5. Okay, I did that real quickly in my head, trial and error. If you need to take a second and do AC method, but don't take forever, you should be factoring like a pro by now, right? So, and then what? Either 0 equals 2x plus 1 or 0 equals x minus 5. We did this earlier, right? In test 1 material. Solve that. One of those factors has to be 0 in order for the whole multiplication to be a 0. Solve for x. 2x equals -1. Subtract the 1 off. Divide by 2, -1/2. And then here, solve for x, add the 5, x equals 5. Okay. There are my two critical values. Okay. X is -1/2, x is 5. So I've done step 3. Step 4 is the sign chart. So this is kind of the only weirdish step. I've got two critical values here. And on the, let me think about this. Here's my 0. Here's -1. Right in here is -1/2, right? And then 1, 2, 3, 4, 5 is out here. Okay. So on this, these are kind of my breaking points, right? This is what sections my chart off. I've got negative stuff, I've got stuff close to 0, and then I've got positive stuff. I'm going to go ahead and pick a 6 out here. Okay. All right. So on the top, I'm going to put f prime of x. On the bottom, I'm going to put f of x. Okay, so these are zeros. I know they're zeros because I forced it to be 0. I took the derivative and I said equals 0. They are zeros. They are critical values. We'll find out if they're maxes or mins in a minute, okay? And then, so we got our sign chart, test points. That's the biggie here, okay? I need a test point on the left-hand side, I need a test point in the middle, and I need a test point on the right-hand side. I'm going to use x equals -1. It's right here. I'm going to use x equals 0. It's right here. And I'm going to use x equals 6. Okay, it's right there. Okay. So what are we after? We're going to plug those numbers into the derivative, which is right there. Okay. 12x squared minus, oh, let's use this guy. He's nicer. I divided by 6. We should be fine. Okay. So 2x squared minus 9x minus 5. So plug in f prime of -1, and I get 2 times -1 squared. 9 times -1 minus 5. Okay, what happens when I square this guy? It's a positive, right? 2 times 1 is 2. Negative and a negative becomes a positive 9 minus 5. Okay, this guy is definitely positive. And again, we don't really care, okay, what positive value it is. We just care that it's positive. And remember, these critical values are splitting up my sign chart. So if -1 is positive, then -2 and -3 and -500, everything over there is positive. Okay. Now, my next critical value, or my next test point, I'm sorry, f prime of 0. 2 times 0 squared minus 9 times 0 minus 5. That's a 0. That's a 0. This is negative 5. What I care about is that it's negative, right? Okay. Don't really care about the value, just that that center section is negative. Okay. And then the last section, f prime of 6, because I'm looking on the right-hand side here, right? Said I was going to use a 6, is 2 times 6 squared minus 9 times 6 minus 5. And I could figure this out. Well, I should actually because it's a minus 9. Let's make sure it's working. 6 times 6 is 36. 2 times 36 is 72. Is that right? Check me. Okay. Minus, this is 6 times 9, 54, minus 5. Okay. I'm not going to do that in my head. You don't have to do it. What I know is that this guy is a positive number, right? That's what I care about. So sure enough, it's a 13. Again, I don't care that it's a 13. I care that it's positive because that tells me everything on the right-hand side there is a positive. All right, so thinking about it, that means this piece is increasing, this piece is decreasing, this piece is increasing because remember, these are slopes. Okay, when slope is positive, my line's going up. When slope is negative, my line's going down. When slope is positive, my line's going up, which means if this went up and then down, right here, I've got a what? Maximum. And down and then up, right here, I've got a minimum. Okay, and this is an increase. This is a decrease. This is an increase. Okay, so that is how I do this. Technically, ask me for intervals of increase, decrease, or constant. So let me give those intervals. Okay, it is increasing from this section right here, negative infinity to this was negative 1/2, or it's increasing from 5 to positive infinity. Okay. Those are my intervals where it's increasing. It's decreasing from this point to this point, right? So it's negative 1/2 up to 5. Okay. And then last but not least, it asks for maxes and mins. So there's a max at x equals negative 1/2. If we wanted to, we could find that y value. Where do I find this y value? Do I do it from the derivative? No. This is actually a point on the graph, right? So if I want that y value, I got to go all the way back up here to the original f of x. So just be aware of that, okay? And there was a min here at x equals 5. And that's the point, oops, not infinity. 5 comma, I don't know what that value is. Go plug it back into the y if you really want to see it. Okay, whew. That's a lot for the first derivative test, right? All right, so that's first derivative. The second derivative, like I said before, it's going to work exactly the same with the same steps here, except for it's going to say take the second derivative. Now we know, and this number 16 basically tells me to continue. So we know that f prime of x was 12x squared minus 54x minus 30. Okay, that was my derivative. So I'm going to use the same steps to work out the second derivative test. So to find the second derivative, remember the second derivative is the derivative of the derivative, right? So I'm going to take the derivative right here. 24x, that becomes 2 minus 1 is a 1, minus 54, that x goes away, and the derivative of a constant is 0. So there's my second derivative. You should, again, be that quick by now, hopefully, with the power rule so that you can do that. There's my second derivative, and then we're just going to work our way through. Okay, take the derivative, set it equal to 0. Solve for the variable 24x equals, I'm going to add this 54 over. 24x equals 54. Solve for the variable. I'm still multiplying by 24. I'm going to divide by 24. X equals 54 over 24. And I am going to reduce this just a tiny bit because I see that they're both divisible by 2, and I feel like, hey, why not? 27 over 24 is 12. You can use either one of those, but there you go. Okay. At any rate, this is about, or it is 2.25. So 2 and a fourth, basically, right? Okay, so you can divide all that out, whatever you need to do. Okay, so I've got my critical value right there. By the way, there's only one here, right? Because this was x squared. Earlier, my original was x cubed. So when I took the derivative, I had x squared. That was two critical values, right? Because it was a parabola. But here, I'm starting with x squared, and this is a line. It's linear, so there's only one critical value. It decreases when my degree decreases. All right, got my critical values. Step 4, sign chart, test points, and interpret. Number 5. Okay. Sign chart. Here we go. 0, 1, 2, 3. Now you know why I wanted to know the decimal approximation. Or you could just say, hey, 24 is 2 12s, right? Oops, 1, 2, 3. So this guy is right in here. He's a 0. This is double prime, f double prime. And this is my original function. Okay, so the critical value at x equals 2.25. Okay. I need to pick test points. I'm going to pick x equals 0 and x equals 3. Okay. And we're going to plug it in. I'm going to come back up here and plug into this guy, f double prime of x. So f double prime of 0, 24x minus, or 24 times 0 minus 54 times 0. That guy goes away. This is a negative 54. That's negative. Okay. Negative, negative, negative. Okay, probably this is going to be positive, but we did see some examples when we were working stuff up where sometimes it's not. So let's just be double sure. I'm going to put in x equals 3, like I said. F double prime of 3 is 24 times 3 minus 54. Must be getting tired, getting old, sloppy. 72 minus 54 is a positive number, right? You can figure out what it is. I don't care what it is. I care that it's positive. Okay, so let's interpret. Everybody okay? Sign chart, get your test points, plug them in, get your positives and negatives. And remember, okay, this is concave down. And this is concave up. And I heard something really nice the other day. So for concavity, if it's up like a cup, it looks like that, right? Meaning it would hold something. If it's down like a frown, okay, it looks like that. So that's down like a frown. It's negative. Negative people are unhappy. This is positive. Positive people are happy. Frowny face. This is a smiley face. Whatever it takes for you to remember that. Okay. So the question becomes, did this thing change concavity? This is concave down. Then right here is my critical value, 2.25, and this is concave up. And the answer is yes, it changed concavity. So if it changes concavity, then this guy right here is a point of inflection, right? It's the point where the graph switched its concavity. So again, it asks for intervals for concave up and intervals for concave down. So it starts its concave up here at 2.25, or let's call it 54/24, and it's concave up all the way out to infinity. That's my interval. And intervals for concave down, that's the frown. Well, that starts way out here at negative infinity and goes to that critical value, right? Okay, and then we do have a point of inflection, and it's at the point 54/24. I don't know what his y value is. How do you find it? You go back to the original. All right. Whew, okay, that is a lot of derivative stuff. And this video is starting to get long. We're done almost with test 2 stuff. And then I feel like we just did test 3 and test 3 review. So I'm not too worried about getting really in depth on that stuff, but I do want to hit test 2, this one last topic, which is it was actually like the original topic when we studied derivatives, but I moved it to the end of test 2 so that it's not quite as stressful for everybody. And here's what it looks like. You've got a function. Okay. Oops. And what we want to do is we want to show the derivative by definition. Okay, derivative by definition. So if you'll remember, f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h. Okay, and remember we call this a 4-step process. I generally will list these out for you. So step A here says find f of x plus h. Okay, so you have to do the 4-step process. You have to start right here. Okay, you cannot just take the shortcut here. I'm looking for these steps. You must show me the whole process. And step A here is, in my opinion, where most people struggle. Okay, everywhere we see an x, we're going to substitute in x plus h. So f of x plus h is 6 times x plus h squared minus 5 times x plus h plus 7. Okay, there's that. Okay. The substitution step's not what bugs most people. It's this guy right here. So again, hopefully by now we've done this a gazillion times. X plus h squared means x plus h times x plus h, right? You can distribute this guy out. That's x squared plus xh plus xh plus h squared. If you don't remember him, it's okay to go ahead and distribute that guy out. But hopefully, a lot of us know by now that we can just substitute that in. It's 6 times x squared plus 2xh plus h squared. Minus, this guy gets distributed through 5x minus 5h plus a 7. All right. And then this 6 needs distributed. So be careful as you do that. F of x plus h equals 6x squared plus 12xh plus 6h squared minus 5x minus 5h plus 7. And there aren't any like terms in there, so that is your first step. Okay. Whew. Step A. Then B is show me where you're subtracting this. So we just go ahead and do the entire top now. So B says find f of x plus h minus f of x. Well, we just got this guy, so write him down, right? 6x squared plus 12xh plus 6h squared minus 5x minus 5h plus 7. And I'm going to say, don't try to save paper here. It's okay to take extra paper because we need it, okay? If you miss points here because you were trying to not write everything down, then you will be kicking yourself, okay? So it's minus the original function, which is all of that, and you better put it in parentheses because why? Because it's minus here, and that negative needs to go distribute through, right? So be aware. All right. Now, if I did this correctly, and you need to show me this, you can't just know that this stuff's going away and just dump it. You have to show me that you distributed that negative, negative, positive, negative, and then you come back and you say, that guy goes away with that guy. Okay. This minus 5x goes away with this positive 5x. And this positive 7 goes away with the negative 7. If I did it right, everything that I just distributed through should go away, right? And the stuff that's left over, 12xh, 6h squared, and a minus 5h, all of that stuff is the stuff that's left with the h's in it, right? Get rid of all that other stuff. It goes away. And now I just have h's left, okay? Which leads me well for step C, because step C says now divide by h, right? Leave that limit guy till the end. Now we're doing this whole fraction. So find f of x plus h minus f of x all over h. Now, do I need to go back and redo this stop stuff? No, I have that, right? This is what f of x plus h is, minus f of x. 12xh plus 6h squared minus 5h all over h. That's what we're saying. Substitute that in right there. Okay. If you are not quite sure, remember that this has an h, this has two h's, and this has an h. I'm going to factor out an h here. Okay. Factor out that h. One of these goes away, but one h is left. Remember that. This h goes away and this h goes away. If you're really good with that, excuse me, and you feel confident to pull the h out of each term without writing it as factored, I'm not going to hate you. But if you mess that up, you might be mad at yourself. Okay. So just be aware that's an easy spot to make a mistake if you are trying to save paper. So write it out if you need to. All right. Last step. Find the limit as h goes to 0 of all that stuff. Okay. Well, I already have all this stuff, right? That's that. So put it here. Just put the limit as h goes to 0 out in front. Okay. And remember what that means. When I take the limit here, I'm literally saying plug in 0 for h. Okay. That's going to go away and that's going to go away. Anything left hanging around that has an h in it just goes away. And what I get is 12x minus 5. Okay. So that is the 4-step process, and you will have one, and it will be worth a lot of points. So make sure you can do this. We did this as a quiz by hand. You've done it in homework. You did it on test. Make sure you can do it real quickly. Let's check ourselves. This was my original. Use your shortcut. 12x, subtract 1, 12x minus 5. That guy goes away, right? Oops. 12x minus 5. Check. There's no reason why anybody taking this test will miss this problem except that we just like mix up our negative signs or something. We don't distribute properly, something like that, because you know what the answer should be. You can use your shortcut rules, so use it to check yourself. You have to do the process, all 4 steps, but you can certainly use them to check yourselves. Use the shortcuts for that. All right, that's all I'm going to talk about for exam 2. So we're in the home stretch here. Exam 3 material. All right. Again, we just took this exam 3, so hopefully you are okay with it. I'm going to do just a couple of examples of solving systems of equations. This is off of an old test again. So solve using elimination. It says 5m minus 7n equals 9, and 2m minus 12n equals 22. There's my system of equations, if you remember this. Do something. That's an m. Those are n's. Do something to eliminate one of the variables. I think what I would like to do is multiply this entire first guy by 2 and this entire second guy by negative 5, because I see that if I do that, these will go away. So let's see. That's 2 times 5m is 10m. Distribute, right? All the way through the entire equation function there. Okay, 2 times negative 7 is negative 14n, and 2 times 9 is equals 18. Okay, and then here, negative 5 times 2 is negative 10m. Negative 5 times negative 12 is positive 60n. And negative 5 times 22, oh my gosh, is that 110? Yeah. Negative 110, right? Because it's negative 5. All right. That's what I've got now. And this sets me up well for eliminating. I'm going to add these two functions. The 10m's go away. 60 minus 14, I don't know what that is. 46 n. And be careful here. It's negative 110 plus this 18. Okay. And so remember that you subtract and take the sign of the bigger one. If you're not sure about that, punch it on your calculator. You can do it. Okay. It ends up with a negative, and the difference between those is 92. And then the last step, divide by 46. Should be a 2. Yep. N equals 2. All right. So I've got n equals 2. Am I finished? No, you're not finished until you have an m value as well, right? So I'm going to take this 2, I'm going to plug it right there, okay? 5m minus 7 times n equals 2 equals 9, okay? 5m minus 14 equals 9. I'm going to add the 14 to both sides. 5m equals 9 plus 14. Hang on. I feel like I've got an issue. Hold on. What did I do? Minus 14. 9 plus 14. Hold on. Let me check my math here. Let me see that I did it right. Ah, I see it right here. The little stinker. Look at this. Negative 92 divided by positive 46 is a negative 2. Those negatives, man, they get us all the time. N equals negative 2. I'm sorry, guys. So I'm plugging this in. Let me start over with the plug-in. This is just ugly. I'm sorry. 5m minus 7 times negative 2 equals 9. 5m plus 14 equals 9. That'll make a difference here. Whenever I go to subtract 14, okay, it's just the sign, the difference of a negative sign. It makes a huge difference. 5m equals 9 minus 14 is negative 5 instead of 23. I knew it should have gone in evenly, and I was like, ew, that's ugly. That's not right. Okay. Divide by 5. M equals negative 1. Okay. So M equals negative 1. Remember that these go in alphabetical order. It's M before N. So I've got, I've got negative 1 comma negative 2. Or you can just say, here's my M, here's my N. A lot of you did that. I think on a test, sometimes people were like, oh, I don't know which one goes first. So they didn't want to mess with it. Okay. Without working one of each special case, I just want to make sure everybody remembers. Okay. We might end up with one in a minute. But if I end up with 0 plus 0 equals 12, okay, you're going to say that's a false statement. And you're going to say no solution. Okay. It's not enough to just put an X or something like that. You need to interpret this and tell me what the heck it means. But if I ended up with 0 plus 0 equals 0, that's a true statement. And what that tells me is that there are infinite number of solutions here. It's like the two lines are just on top of each other, right? So be sure that you know the difference. Some of you didn't know the difference, and so you said no solution, infinite solutions, and you knew it was one of them, so you figured you'd get partial credit. But make sure you know for sure if it's a lie, this is not a true statement, it's false, no solution. If this is a true statement, 0 always equals 0, right? So always. Then you're going to say, oh, that means there's infinite number of solutions. So those two special cases, keep an eye out for them. You'll probably see one here or there on the practice test or on the final exam. Not practice test. On the final exam. So hopefully you guys know how to deal with them, right? Okay. Let's move on to matrices. So on the test I'm looking at, this is number 5. It says, write an augmented matrix and solve using appropriate row operations. Okay. When I say that, that means row operations means matrices, right? So it doesn't mean write it as an augmented matrix and then go back and solve it the way we just solved those other ones. It means you better be using a matrix. Okay, so use your matrix. That is the skill I'm testing for. Okay. So augmented matrix, it's going to be my 2 by 2 here plus the solutions. They're augmented onto it. So that's my augmented matrix. And then remember that what I would like to do is I want to manipulate this and to solve. I want to manipulate this so that I end up with 1, 0, 0, 1 and some numbers over here. And once I get there, I'll be able to say, so X equals this number, Y equals this number. Okay. So we want to get there. We want to go back to the, after we're finished, we can read this top line. We can read that second line. That will give me solutions. Hopefully. Excuse me. Hopefully it's not a no solution or something. So we actually get an answer here. We'll see. All right. So I think, so using appropriate row operations, I think Normally, I'd try to move these around or rearrange or something, but this is kind of nice because it's a 3 and a 2. Remember, we want the 1 here first. So this is my first. Then second, I'll go for this 0. Then third, I'll go for this one. And then last, I go for that 0 up there. There is an order that keeps me from going around in circles and undoing math and redoing math. So I think if I want a 1 up here, I see that, hey, 3 minus 2 would be a 1, right? So it's kind of set up nicely that if I just multiplied through here by a -1, that I would be able to subtract that from the 3 and I'd be good. Okay. So remembering that I don't want to mess up my second row. I don't actually want to change my second row. I just want to use it to manipulate the top row so that I get a 1 in that first row, first column position. So 2 times -1 is -2 plus 3 is a 1. -1 times -1 is a +1 plus 2 is a 3. And -1 times a 5 is a -5 plus 4 is a -1. Okay. Now I've got that 1 up there. Now I want a 0 here. Okay. And I'm going to do a similar thing, but I'm going to multiply the top row by -2 and add it down. Okay. But again, I don't want to mess up that top row. I just got that 1 there. I want it to work nicely. So I'm going to rewrite the top row. And then I'm just going to do this math right here. Okay. -2 times 1 is -2 plus 2 is a 0. -2 times 3 is a -6. -6 plus -1 is a -7. And -2 times -1 is a +2. +2 plus 5 is a 7. Okay. And hopefully we get some nice numbers. If it's just a little bit of a fraction, it's not that big of a deal. But hopefully they're not bad. I need a 1 here. So remembering that if I want a 1, normally I'm going to multiply through by something. If I want a 0, normally I'm going to multiply the other row by something and add it. Okay, normally that's what I do. So I want this guy to be a 1. I'm going to multiply him by -1/7 right here, just straight through on that bottom row. Not going to change the top row at all. Okay, so 1, 3, -1. And then here, 0 times the -1/7 is a 0. -1/7 times -7. Negative and negative is a +1. Negative and a positive here is a negative, but -1/7 times 7, 7 over 7 is a -1. Okay, so this is starting to come together nicely for me. My last thing, I got the 1, the 0, the 1, the 0. Last thing is I want this guy to be a 0. Okay, the bottom is exactly what I want it to be. So I'm going to rewrite it here, 0, 1, -1. And again, I'm trying to make a 0, so I'm probably going to multiply this by something and add it up. It's a -3 plus. And the nice part is because I just got this 0, -3 times 0 is 0, plus a 1, that's just the 1. It doesn't change. -3 times 1 is -3 plus the 3 is a 0. -3 times -1 is a +3. +3 minus 1 is a 2. Okay. And again, woohoo! I got this 1, 0, 1, 0. That's a nice format. If I want to read this, it's 1x plus 0y equals 2. Well, that's just what? X equals 2. And 0x plus 1y equals -1. And that's just a 0, so y equals -1. And if I want to, I can write that as a point, 2, -1. There it is. All right, so that is how we do those things. Most of you did really well with the adding and the subtracting and the multiplying by a scalar number. Excuse me, multiplying by a constant. So all I'm going to say is remember that in order to add or subtract, you must have the same size, right? Same size matrix. If it's not, then you can't do it, okay? Let's just see this one right here real quickly. Okay, multiplying, and it'll be a little time sign, right? Multiplying this 6 through, in this case, because this is just a constant, it means multiply each term, right? So 6 times 1 is a 6. 6 times 3 is an 18. 6 times 7 is a 42. Okay, keep going. 6 times 0 is 0. 6 times 1 is a 6. 6 times 5 is a 30. Keep going. You're not finished. Do every single term by the 6. 6 times -2 is -12. 6 times 0 is 0. 6 times 4 is 24. And most of you did really well with that, multiplying by a constant thing. A couple of you struggled a little bit with it just because maybe you didn't realize every single term was going to get multiplied. So be careful of that. All right. And then the one that about half of you still struggled with was, what if I want to multiply two matrices? So 2, 4, 6, 8. Who do we appreciate? -1, 3, 0, 1. All right. Now, before I do this, what do? I check. 2 by 2 is this guy's dimensions times 2 by 2 is this guy's dimension. And what am I checking? I'm checking that these inside numbers match, okay? The number of columns here is the same as the number of rows there. You have to have that in order for this to work out. And then how big is my answer matrix going to be? A 2 by 2, whatever's left over, right? 2 rows by 2 columns. If that was a 3, it would be 2 rows, 3 columns. So we have to do it the way it's supposed to be done. Okay. So because these two middle numbers match, we're going to go first row by first column. And I really recommend you do this step by step. It's not terrible. 2 times -1, so it's first guy times first guy. 2 times -1 is -2, plus 4 times 0, because it's second guy times second guy is a 0. Okay. Then it's first row times second column, and that will give me the piece that's going to be in the first row, second row column spot. 2 times 3 is 6, plus 4 times 1, second times second, is 4. That's going to be first row, second column. He goes right there. Okay. I need 2 more pieces because remember, this is a 2 by 2 answer. I need this guy. Well, what is he? He's second row, first column. So second row times the first column. 6 times -1 is -6, plus 8 times 0 is 0. Second times second. And then the last guy is second row, second column. 6 times 3 is 18, and plus 8 times 1 is an 8. Okay. Now it's just a matter of making that pretty. -2 plus 0 is -2. 6 plus 4 is 10. -6 plus 0 is -6. And 18 plus 8 is 26. All right. So Some of you got a little bit mixed up on some of those. Make sure you can do those. It's a rhythm for first times first, second times second. But once you get there, I think you'll be okay. So, when can't you multiply? If these two numbers in the center don't match, then you would say they don't have the correct dimensions. It's not that they're not the same size. These happen to be both 2 by 2. But remember, if this is a 2 by 3 times a 3 by 4, the 3's match, you would end up with a 2 by 4. So all that has to happen is that number in the middle has to match. All right, and let me do the one last thing. There's some other stuff on this, but again, we just took this test, so I feel like you should mostly be okay with the matrix stuff. But let's talk inverses. Okay. If two matrices are inverses, then when you multiply them, you will get the square matrix, the identity matrix. So if it's a 2 by 2, it's 1, 0, 0, 1. If it's a 3 by 3, then it's 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, you'll get one of those, right? Okay, because we're not doing anything bigger than 3 by 3s for sure. Okay, so you will get that. So when you multiply stuff, the question on the test said, are these inverses? Number 8. And it's not enough to say just yes or no. You need to show the work. Okay. Now I'm going to say a couple of you have probably taken like a college algebra class or something, and you know a little bit about what this pattern looks like, or maybe you know a little bit about determinants. Ooh, things like that. I saw some of those types problems being worked where you did determinants. That's fine. Just realize it's not the method that I'm showing you, but I gave you credit if you did another method. It was okay. It just wasn't what I was after. Okay, -5, 2, -8, 3. And the other one that we want to know if this is a matrix for 3, -2, 8, -5. But if you're using determinants, you absolutely have to show me the math, like what's your A, what's your B, what's your C, what's your process, okay? So we're going to multiply these. And if we get this, because they're 2 by 2s, if we get this identity matrix, then they are indeed inverses. So -5 times 3 is -15 plus 8 times 2 is 16. Okay. I don't have to, if this isn't a 1, which it is, then I can stop because that means it's not working. Okay. But that is, so we're going to keep going. First row times second column. -5 times -2 is a +10 plus 2 times -5 is a -10. That's a 0. Hey, that's also what I needed. 1, 0. This guy better be a 0, right? Second row times first column. -8 times 3 is -24 plus 3 times 8 is 24. Hey, look, that's a 0. And second row times second column. -8 times -2 is a +16. 3 times -5 is a -15. 16 minus 15 is a 1. So look at that. I got 1, 0, 0, 1. Okay, so yes, they are inverses. And again, you have to spend just a second giving me your interpretation. It's not enough to just show me 1, 0, 0, 1. You have to show the work that you did to get here, and you have to answer the question. Yes, these are inverses. So don't just think that because I see this 1, 0, 0, 1, that means that you answered the question. You need to actually answer the question. Okay. Real quickly, I'm not going to work number 9, but I want to kind of throw something out there. The way you find something's inverse that we showed in this class, it's the way it shows it in your book, is that you take the inverse, or I'm sorry, you take your matrix and you augment it with the identity matrix. And then you solve this. You want this to turn into 1, 0, 0, 1 with some numbers. And then this matrix, if you get there, if you get a solution, this matrix, if it's not a no solution, basically, this matrix is your inverse. Okay, you know that you're messed up if you get like 0, I don't know, something that's not an inverse, then you're in trouble. Not a matrix. Okay, but you're gonna get something there. Okay. Oh, excuse me, I'm not trying to test you for weird inverse stuff. Okay, so what you can't do is you cannot multiply these, and I actually saw several people do it. -5, 3, 2, -2. You can't multiply times 1, 0, 0, 1 because I don't even have to do that math. If I multiply any matrix by the identity matrix, I better get back the original matrix, right? So matrix times identity equals matrix. Okay. So several of you multiplied these instead of augmenting. You need to augment that matrix. Several of you multiplied these, and sure enough, you got this back. And then when you get to multiply these two together, it should be matrix times matrix inverse gives me back the identity, right? Okay. But you didn't get that. And so you went, oh, this didn't work. Okay. But that's not because it doesn't have have an inverse. It's because you multiplied it by the identity. So of course you got the same matrix back. Okay. So just be careful about that. That's an overview of test 3 material. I feel like everybody did pretty well on test 3. So probably you're doing okay. But just in case, there it is. Good luck studying for the final. Good luck taking your final this week. And I wish you all the best as you wrap up this semester. Take care. Bye.